name is L. Baba Fakhruddin. My topic is integration. Change the order of integration. Change of order of integration implies that the change of limits of integration. If the region of integration consists of a vertical strip and slide along x-axis, there is a changed order consisting of horizontal strip and slide along y-axis and vice versa. Always it is better to draw a sketch of region of integration. Suppose the given integral is integral x to x equals to a to b, integral y equals to f1 of x to f2 of x, f of x comma y dy by dx. The region of integration consists from x equals to a to x equals to b and y equals to f of 1 f of x to y equals to f2 of x, where x is fixed and y varies. Then we take vertical strip along parallel to x-axis. The limits of change of order of integration consist y are fixed and x limits varies, that is y equals to b to y equals to a to b and x equals to f1 of y to x equals to f2 of y, which consist of horizontal strip parallel to x-axis along y-axis, that is y limits varies vertical strip, x limits varies horizontal strip. My problem is determine the integral by changing the order of integration. Integral 0 to 4a integral x square by 4a to 2 root ax dy by dy into dx. Solution. In the given integral, for a fixed x, y varies from x square by 4a to 2 root x and from x varies from 0 to 4a. Let us draw the curves y equals to x square by 4a, that is x square equals to 4ay, and y equals to 2 root x, that is y square equals to 4ax. We see the diagram. The curve, the parabola is on the x-axis, x square equals to 4ay. Another one is y square equals to 4x on the y-axis. The parallel is PQ is parallel to x-axis. The region of integration is the shaded region in figure. The given integral is integral x equals to 0 to 4a, integral y equals to x square by 4a to 2 root ax dy dx. Changing the order of integration, we must fix y first. For a fixed y, x varies from y square by 4a to 2 root ay, and then y varies from 0 to 4a. Hence the integral is equal to, we have fixed y limits, y equals to 0 to y equals to 4a. For y x limits, x equals to y square by 4a to x equals to 2 root ay. We see the problem. Integral y equals to 0 to 4a, integral x equals to y square by 4a to 2 root ay dy by dx equals to integral y equals to 0 to 4a, integral x equals to y square by 4a to 2 root ay dx whole dy. Integral, first we differentiate the dx, x differentiation, one integral 1 x, first upper limit minus lower limit, integral y equals to 0 to 4a 2 root ay minus y square by 4a into dy, that is integral y equals to 0 to 4a 2 root ay dy minus integral y equals to 0 to 4a y square by 4a dy. We separate the constant 2 into integral y equals to 0 to 4a 2 root a root a into root y dy minus 1 by 4a integral equals to 0 to 4a to y square dy. We separate the constant outside, root a 2 root a into y equals to 0 integral 4a y whole power 1 by 2 dy minus 1 by 4a integral y equals to 0 to 4a y square dy, 2 root a into y power 3 by 2 by 3 by 2 limits 0 to 4a minus 1 by 4a into y cube by 3 in limits 0 to 4a 2 root a into the 3 by 2 in the denominator, it comes in multiplication 2 by 3 into 4a whole power 3 by 2 minus 1 by 12a into 4a whole cube 4 root a by 3 into 4 square is 2 we write 2 square whole power 3 by 2 2 to cancel a power into 3 into a power 3 by 2 minus 1 by 12a into 64 a cube 4 into a power 1 by 2 into a power 3 by 2 into 8 by 3 minus 64 a square by 12 we divide it by 4 64 divides 4 means 16 12 means 3 therefore 32 a square by 3 minus 16 a square by 3 it means 16 a square by 3. Thank you.